Articles 250.66 and B provide an exception to the general sizing rules found in Table 250.66 of the National Electrical Code. This exception applies specifically to the section of the grounding electrode conductor that forms the sole connection to the grounding electrode itself. Let's break this down further. Consider a typical ground rod installation. The grounding electrode conductor connects the ground rod to the grounding busbar or neutral point at the service equipment. Article 250.66 and B state that the portion of this conductor acting as the only link to the grounding electrode, such as the ground rod, isn't required to be larger than 6 American wire gauge copper or 4 American wire gauge aluminum. This means that a smaller conductor is permitted for this specific segment compared to what Table 250.66 might otherwise dictate. To clarify, this exception focuses on the direct connection to the grounding electrode. The remaining portion of the grounding electrode conductor, for example, the part running from a junction point to the service equipment, must still adhere to the sizing requirements outlined in Table 250.66. Think of it as two separate sections of the same conductor, each potentially with different sizing requirements. Let's illustrate with an example. Suppose the largest ungrounded service entrance conductor in a building is rated at 200 amps. Consulting Table 250.66, you'll find that a copper grounding electrode conductor would typically need to be 2 American wire gauge. However, if you're using a ground rod, the portion of the conductor connecting directly to the rod can be 6 American wire gauge copper, thanks to the exception in Article 250.66a. The rest of the grounding electrode conductor, from that connection point back to the service equipment, must still be at least 2 American wire gauge copper. Why is this exception in place? The reasoning behind it lies in the characteristics of grounding electrodes. Ground rods, for instance, have a relatively high resistance to earth. This resistance limits the amount of current that can flow through the conductor directly attached to the rod. Because of this current limitation, the code permits a smaller conductor size for the specific connection, acknowledging that a larger conductor wouldn't necessarily improve the grounding system's effectiveness in that particular segment. It's essential to understand that this exception does not apply to the entire grounding electrode conductor. Only the portion forming the sole connection to the grounding electrode benefits from the reduced sizing requirement. The rest of the conductor must be sized according to Table 250.66, based on the size of the service entrance conductors. Now let's talk about the practical implications. When installing a grounding system with ground rods, carefully consider where the exception applies. Clearly identify the section of the grounding electrode conductor that directly connects to the rod. This section can be sized according to Article 250.66a, allowing for a smaller conductor. Ensure that the remaining portion of the grounding electrode conductor connecting to the service equipment is sized according to Table 250.66. Proper labeling and documentation can help ensure compliance and avoid confusion during inspections. Keep in mind that local amendments to the National Electrical Code may exist. Always consult with your local electrical inspector or authority having jurisdiction to confirm the specific requirements in your area. Variations in soil conditions and other factors can influence grounding system design. Grounding electrode conductors are critical for safety, providing a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers and fuses. A properly sized grounding electrode conductor helps to minimize voltage rise during fault conditions, reducing the risk of electric shock. When making connections to ground rods, use approved connectors designed for direct burial. These connectors resist corrosion and ensure a reliable connection over time. Inspect grounding electrode conductors periodically for damage or corrosion. Replace any damaged conductors immediately to maintain the integrity of the grounding system. When multiple ground rods are used, the grounding electrode conductor must connect to all of them. The portion of the conductor connecting each rod can be sized according to Article 250.66a, while the main conductor connecting back to the service equipment must meet the requirements of Table 250.66. Consider the material of the grounding electrode conductor. Copper is a common choice, but aluminum is also permitted under certain conditions. Ensure that the conductor material is compatible with the grounding electrode and connectors to prevent corrosion. When using aluminum conductors, follow the manufacturer's instructions for proper installation and termination. Aluminum conductors require the use of antioxidant compounds to prevent oxidation at connections. Ensure that grounding electrode conductors are protected from physical damage. Route conductors in a way that minimizes the risk of impact or abrasion. If necessary, use conduit or other protective measures to safeguard the conductors. Grounding electrode conductors must be installed in a neat and workmanlike manner. Avoid sharp bends or kinks in the conductors, as these can increase impedance and reduce the effectiveness of the grounding system. Grounding is a fundamental aspect of electrical safety. A well-designed and properly installed grounding system protects people and equipment from electrical hazards. By understanding the specific requirements for grounding electrode conductors, you can ensure a safe and compliant electrical installation. The National Electrical Code is a comprehensive set of rules and guidelines for electrical installations. It is important to stay up to date in the latest edition of the code and to consult with qualified professionals when designing or installing electrical systems. Article 250 focuses specifically on grounding and bonding requirements, providing detailed information on grounding electrode conductors, equipment grounding conductors, and bonding jumpers. Table 250.66 is a key reference for determining the size of grounding electrode conductors based on the size of the service entrance conductors. The table provides minimum conductor sizes for both copper and aluminum conductors. When sizing grounding electrode conductors, always refer to the latest edition of the National Electrical Code and consult with a qualified electrical professional. Improperly sized grounding electrode conductors can compromise the safety and effectiveness of the grounding system. Remember that the goal of grounding is to provide a low impedance path for fault currents, facilitating the operation of overcurrent protective devices and minimizing the risk of electric shock. A properly grounded electrical system is essential for protecting people and equipment from electrical hazards. When working with electrical systems, always follow safe work practices and wear appropriate personal protective equipment. Electrical work can be dangerous, and it is important to take precautions to prevent accidents. If you are not qualified to perform electrical work, consult with a licensed electrician. A licensed electrician has the training and experience to safely and effectively install and maintain electrical systems. Grounding electrode conductors play a vital role in electrical safety, and it is important to understand the specific requirements for their installation and sizing. This understanding of the exception provided in 250.66 and B can help to optimize the grounding system while maintaining code compliance. Always prioritize safety and consult with qualified professionals when working with electrical systems.